Hey guys, so today we're going to be doing a little science demonstration. So here we have a cork in a mason jar surrounded by water. As you can see, the cork is floating in the water and would float to the top of the jar if it weren't for the green string that's tying it down to the lid. Now what I want you guys to think about before we do anything with this mason jar full of water is think about the reason for why the cork floats in water to begin with, and why it doesn't sink to the bottom or sink at all. Why does it float in the water? Okay, so the reason why the cork doesn't sink to the bottom has everything to do with density. Because the volume of the water that the cork is pushing out of the way weighs more than the cork itself, that makes the water want to push the cork out of it. The reason why corks float in water has everything to do with density. The cork itself weighs very little, and the volume that the reason why corks float in water has everything to do with density. The volume of the water that the cork pushes out of the way weighs more than the actual cork itself, so that the water wants to push the cork up and out of the water. The reason has all to do with density. The cork, when it's in the water, is taking up some of that room that the water wants to be in. So, because the water weighs more than the cork itself, it wants to get into that area that the cork is taking up, so it's going to push the cork up and out of the water. So, if I give the mason jar a big push this way, I want you to think about which direction do you think the cork is going to go in, keeping in mind density and what we know about physics already. So now that you've thought about it, I want you to watch the cork and pay special attention to which direction it moves in as I give it a push this direction. I'm going to do that again. Watch carefully. Alright, now turn to your partner and talk about what happened. So what you guys should have observed was that the cork moved in whatever direction I was pushing it in, or whichever direction it was accelerating in. Because the first initial acceleration was in this direction, the cork was also going in that direction. But as soon as I started slowing down, then the cork moved back the other way. Now the reason is that the same reason why corks float in water. It has to do with density. We've already established that water has a higher density than the cork that's floating in it, so that when I give the mason jar a push this way, the water wants to stay in place, and it has a higher inertia than the cork, so that all the water wants to move back this way while pushing the cork back the other direction this way. And that is why you get a weird phenomenon with cork in water.